How you guys doing today? Good. So I'm Shawn Glover from Pumptec, and I'm here today to talk to you about the value of Pumptec pumps when utilized with electric inline heaters. So before we start talking about the Pumptec pumps, let's just kind of review briefly why does hot water clean better? So what it comes down to basically is hot water has more kinetic energy. And what that means is your water molecules move faster, okay? And when you put those faster water molecules with a chemical agent, you basically put that chemical on steroid. Because what it does is it speeds up the chemical process, and at the same time, it changes your soil. It gives your soil a makeover. Your soil becomes more soluble, and anytime you have more soluble soil in fibers, it's going to be easier to remove. So electric heaters are commonly used in the industry. Any of you guys use electric heaters in your machines? Or? All right, well then we need to give you a business card. We need to fix that. So electric heaters have a little bit of limitations. That's not saying there's anything wrong with electric heaters. They're fantastic. I love them, but pretty much everything we do in the industry is kind of compared to what we get out of a truck mount heating system, pressure, everything else. So in comparison to a truck mount system, there's some limitations, and one of the limitations is size. Because the component tray that we have in these portable extractors is so small, we have to keep our heater cartridges compact so they're going to fit into that area. Some other limitations is elements and amperage. We're running on 120 volts, so we have to keep our heaters within a 15 amp dedicated breaker, which kind of restricts the size of elements we can use, the wattage we can use on the elements to achieve certain temperatures. And your thermostats. Your thermostats are what dictates the max pressure you're going to get out of your system. And you can use very large thermostats, but when you're dealing with a small inline heater cartridge, if you put too large of a thermostat on, you continue to build heat inside the cartridge, which is going to cause pressure and steam to build, which is going to give you premature failure on your heating system. So those are some of the limitations, but it doesn't mean that they still don't have huge potential. So you guys have probably all heard that you have a 190 degree heater in your extractor, and you go into it thinking, well, I'm cleaning with 190 degree water on my carpet, which on some level is true, because the process that we utilize for cleaning is we set up our machine, we plug it in, we're going to fill our solution tank with water, we're going to prime our pump, which in turn is going to fill our heater cartridge, and then we're going to turn our heater on, turn pump off, and we're going to hook up our wand and our hose, and we're going to pre-spray our carpet, and we're going to agitate it in, and when we finish that entire setup process, we're going to come back and our heater will have shut off because it's reached its max heat potential. So size does matter when it comes to heaters, because most heaters have a capacity of holding half a gallon to 1 gallon a minute of water. So when you start out with 190 degree water and your heater had reached its full potential in that 1 gallon of water, you turn on your machine and you start cleaning, and what you're getting is the max potential of that water for that 1 gallon. So for that 1 gallon, you're going to get about 190 degrees or somewhere around that area. Now, most 500 psi pumps traditionally have done about 1.4 gallons a minute. So when we have a gallon of water in our heater and we're putting out 1.4 gallons a minute, it means that for about 30 or 40 seconds we are seeing that 190 degree rise, okay? But then as the cold water enters your cartridge and the hot water exits, that water's no longer sitting there with the opportunity to build up heat with no water motion coming through, so your overall water temperature is going to drop. And what it's doing is in at about a 20 to 25 degree heat rise with an electric heater. Now, your starting temperature is going to make a huge difference on that, because as you probably know, starting out with cold tap water, you're going to be about 70 degrees. So if you get a 25 degree heat rise out of that, you're at 95 degrees. If you do what a lot of cleaners do and you fill your solution tank with hot water, you're starting closer to that 100 degrees, and now you're at 125 degrees. So the rule of thumb I was always taught in this industry is for every 18 degrees above 118 degrees, you double the cleaning efficiency of your chemical. So if we're getting a 25 degree heat rise and we're starting with 100 degrees, we are increasing our efficiency on our chemical, just not doubling that efficiency. So Pumptec, knowing how important heat was to this industry, we decided we needed to do some research so we could create a true pump solution that's going to optimize the temperature of the water that you guys utilize to clean carpets. So the first thing we did is we wanted to test the current traditional pumps at 1.4 gallons a minute, 500 psi, and ask the question, how much flow do we really need to effectively clean the carpet? Well, we tested the pumps and were astonished. We were able to decrease our flow down to under a gallon a minute and not have any visible difference in the performance that we were seeing in our carpet cleaning process. But what we did see is a 12-degree heat rise. By cutting that water flow, instead of getting a 25-degree heat rise, we were now getting up to 37-degree heat rise. So we were truly now doubling the cleaning efficiency of the chemical, which was our goal. But there were some ancillary values that we hadn't anticipated that removed a lot of risk from the cleaners in the industry. Because we were putting out less flow, the water now that was going down was giving us a faster dry time. Okay? And a faster dry time eliminates our risk of resoiling. We also noticed that we were no longer seeing the moisture in the backing of the carpet or in the pad. So by removing the moisture from the backing and the pad, we eliminated our risk of wicking and long-term delamination of the backing of the carpet. And we also found that size does matter, again. So up until now, most of the 500 psi pumps were running a third or half horsepower motor, drawing about 3.8 to 5.8 amps. Well, by reducing our flow, we were able to reduce down to a quarter horsepower motor at less than 3 amps, which allowed the manufacturers to take that bonus amp draw and put stronger vacuums in or other components to benefit the cleaning process. And we did this testing in the late 90s, and in the early 2000s, the low flow 500 psi pump system was launched, and as of today is one of the #1 500 psi pump systems on the market. Does anybody have any questions? No? Well, I want to thank KleenRite for allowing us this opportunity and setting this whole thing up, and if you guys have any questions, please come over and talk to me and see me. Thank you.